We're going to run through a few more examples for completing the square. This first one, x squared plus 2x plus 2. Remember, with completing the square, I need to have a perfect square trinomial, and here I don't. I can see that readily because the last term is not a perfect square. And so I need to figure out what I need to add in here. I need to fill the blank in. So we need to make a blank. I need to get rid of the 2. We'll move it to the other side. And we'll get x squared plus 2x equals negative 2. Now I left the blank, this blank space, for a reason. Remember, to find the constant in order to complete the square, I need to divide this 2, divide that number in half. Well, 2 divided by 2 is 1. And then I need to square that, raise it to the second power, and 1 squared is 1. So I'm going to add a 1 to the left side of the equation, but I can't just add a 1 to the left side. I'm also going to need to add a 1 to the right side. This is the key step. I think this is a step that most people forget. Once they've got the 1 on the left side, you also have to add it to the right side. It has to be added to both sides to balance out the equation. Okay. Now we're going to do some factoring. So if you look on the left here, this technically is a perfect square trinomial. I'm going to go ahead and factor it immediately, and I'm going to bring down this 1 so it becomes x plus 1. Right, so that 1 is what comes down here. And that is going to be equal to, and if I combine these terms, it's going to be a negative 1. Right? So now we can utilize the square root property. The square root property, or taking the square of both sides, is going to end up with x plus 1 equals plus or minus the square root of negative 1. Right? So I got to take the square root of the right side, add the plus or minus to it. Well, you guys hopefully recognize what the square root of negative 1 is. It's I, right? So this is x plus 1 equals plus or minus I. It's the imaginary unit. And of course, if I subtract the 1 from both sides, I get x equals negative 1 plus or minus I. And so there's two complex numbers here that are solutions to the original equation. They are negative 1 plus I and negative 1 minus I. So my solution set will contain those two complex conjugates. Right? Very good.